For John and Sue this week, they're designing a playground for the children. They're going to use this diagram to determine the area and put them all in the playground. You're going to show all of your math work. So I would think the word area would be important. And as we have worked through several problems already, leading up to, oh, and I have numbers on our papers. You do, and this doesn't. I wonder why. Your papers do, right? Okay. So there's 16 yards here. Yeah. What's here? 10 yards. And how about here? 12. All right. All right. There we go. Okay, so what shapes do you see that we need to find the area of? Abby? Rectangle? Anything else? So if we add the rectangle and the triangle together, we will get the total area, right? And what's the formula for the area of a rectangle? And the formula for the area of a triangle? It's a parallelogram, triangle, triangle, triangle. There you go. 1/2 base times height, and that will give us our area. Okay? And that's where I'm going to leave you with that. Does that make sense? I think you can do it from there. Okay? You're good with that? Once we have our total area then, when we're down here and take a look at this information, the playground company charges 43 cents per square foot. So I want to go back up and look at this. Per square foot is the charge. What might we want to do when we find our area, now that we know we're going to get charged per square foot? Yeah, I would change all of this to feet before I do anything, so that when you get your total area, it's already in feet. Does that make sense? Okay. So somewhere in here, you're going to need to show me your work for changing it over to feet. Yes? No? Okay. All right. And then we know that it gets charged 43 cents per square foot. Per would tell us to do what? Multiply. Okay. So once we know our total area, we multiply that by that 43 cents per square foot, right? Yes, no? Okay. We got that $45 delivery fee, $125 to rake the mulch, and then they want to have a border, $475. Okay. So you show your work down here for that. Do we have questions on that? Yes, no? Okay. Whether you write on this or write on this work, you're going to write on one of those. You don't have to write on both. You will include these words. Circle your words. Circle them. Circle them. Okay? That make sense? Do I need to say any more about the math writing? Okay. Questions? Let's take a look at the rubric and see if there's anything on it that needs to be stated. Product sum total has to be used also. I'm not sure that's wrong. Offset operation. Okay. Any questions? All right. Good to go on that? Doing Friday? Yes? Okay. Let's take a look then at fraction distraction 4 through 6, please. We are using the numbers from the board again. Estimate of the sum of three numbers is 7. The estimate of the sum of three numbers is 9. Again, I would suggest you do the listing of all the numbers off to the side. And that we do the rounding of those numbers first so that we know what we're able to use. You okay, Peyton? Yeah. You're flustered now. 3 and 9/10, what would we round that to? 4. Why 4? Okay. 9 out of 10 is almost the next whole amount. Okay. 2 and 3/10, what would we round that to? Because? Okay. 5/10 is halfway, so 3/10 would be less than half. 1 and 1/5, what would we round that to? Okay, 1/5 is hardly out of the gate, right? Okay, 2.5 out of 5 is a halfway point. 2.5, what would we round that to? 2.5. Because?
Half, if it's half, then we have to.
Okay, half we go on up. And 3 and 4/5, 3 and 4/5. Abby? You didn't like your own answer? Why 4? Pardon? Yeah, 4/5 is almost a whole amount. Okay. All right. We want to know what the three numbers Grace could have chosen. We want her three numbers to equal 7. What three numbers would you pick to equal 7? What three numbers, Jonathan?
2, 1, and 4.
2, 1, and 4 would give us 7. Okay. But we need to go back to the actual 3 that came with those. What are the actual 3 that came with those? Actual 3. Evan. And then number 2, what's the sum of those numbers? So we need to do 3 and 9/10, 2 and 3/10, and 1 and 1/5. Okay? These are already at tenths. The only one we need to change over to tenths would be 1 and 1/5. 1 and 1/5 is how many tenths? Okay? So we have 9/10, 3/10, and 2/10. That's how many tenths? 9, 3, and 2? How many? 3, 2, and 1? Can we leave it as that? No, I had several people last week leave improper fractions as answers. Can we do that? No, so we need to change 14/10 over to a mixed number. What's 14/10 as a mixed number? Lane, thank you for going quickly. How many times is 10 going to 14? So now we have 6 plus 1 4/10, which gives us 7 4/10. Is that in lowest terms?
No.
We can divide by 2 over 2, which gives us 7 2/5. Any questions on any part of that? Yeah. Anybody? Anybody? You would need to finish off 3 and 4. And then do 5 and 6 back here. Make sure you show all your work clearly and neatly. Questions? You may have out your flow chart on quadrilaterals. Yes. There's a half-eaten cookie in your desk.
I see my.
Oh my gosh. Lily, I'll be giving you the assessment here in just a minute.